So question 8 of the May 2018 AS paper 1 Edexcel. We've got a simple model of a lorry, or the speed. We're plotting the speed of the lorry against the cost of the journey. Okay, so speed, or V for velocity here, and a C for cost. Okay, so we get some curve. Okay, don't worry too much about what the curve looks like. Okay, we're going to just really use the algebra to suss out the answers. Okay, but it would be some curve. Okay, don't worry about what it looks like. It's irrelevant. Okay, so when we're doing this question, then we need to think about the techniques that we need and really pick out key words. So when we look at this and it says about minimizing the cost of the journey and the minimum cost of the journey, okay, this reminds you of kind of quadratics or any curve where you're finding, okay, a point where the gradient is 0. Now this would be, this would look like a maximum, okay, but if we just change that drawing, okay, you could get part of the curve that looks like this, and this would be the minimum. Okay, and obviously a company is going to wish to minimize the cost of the journey. Okay, so it makes you think of calculus and it makes you think of differentiation. Okay, so that's what we need to do with this, really. In terms of doing the maths, we need to differentiate this. Okay, so our notation is going to be dc and dv. Okay, but before we try to differentiate this, we really want to write it differently. This is 1500 v to the minus 1. Okay, so I'm going to look at that and differentiate it. So I'm going to bring the minus sign down to the front, okay, and reduce the power by 1. Okay, the next one's easy enough. It's just 2/11 times v, so that differentiates to 2/11, and the 60, when you differentiate it, goes to 0. Okay, so we get this function. Okay, now you could rewrite this. It depends on really what you want to do, but you could rewrite this back to a fraction and put the v squared on the bottom. Okay, it depends on what the question is. Minimizing is when you make the gradient, or dc dv in this case, 0. Okay, so this is why I prefer to write this back as a fraction, so that I can concentrate on the algebra here. Okay, so I'm going to take this negative term over the other side, and then I'm going to take the v squared over here and the 11 over here. So I'm going to get 11 times 1500 equals 2v squared, and then I'm going to divide both sides by 2, and then I can put, we can just put this in our calculator. So v squared equals 8250. Square root that and write our answer to 3 significant figures. That's what it says on the front sheet of the paper, if in any doubt, or if it's not stated, then you round to 3 significant figures. Okay, now that's a velocity, and in this case it's kilometers per hour. Where did I get that from? Well, it says it here. Okay, so what we've done there, and it's really important that when you're thinking through the next parts of the question and stuff, what you're doing and your methods, all I've done is I've just differentiated something and made it equal to 0. This could be a maximum or a minimum. Okay, so they're quite often going to ask us to sort of prove whether that is a maximum or a minimum. Okay, and that's going to come up in part B. Okay, but before that we've got part 2 of part A, if that makes sense. Okay, it says the minimum cost of the journey. So really, if I just draw this on the diagram, okay, if you're finding a minimum, okay, a minimum is a coordinate that has, well, it has 2 components to it. In this case it has a v and it has a c. So all we're really now doing is that we just want to look at, when we choose this value of 90.8 kilometers per hour, what is the cost of the journey. So we need to put this value back into here. Okay, so we're going to do c equals, we've got 1500 over, now 90.8 has been rounded. I would be tempted to get an accurate answer by saying that v is just a square root of 8250. That's a kind of a cheat way of getting a more accurate answer on your calculator, which we need. Okay, if you use rounded answers in the next part, okay, you're going to get a slightly incorrect answer. So pop that into your calculator, you get just over 93 units. In this case up here it does say in pounds. It's important that you look at that, because sometimes it could be thousands of pounds. It might be £93,000. Obviously not in this case. This is just the cost of a journey in a lorry, but it could be a question where that's in thousands of pounds. Okay, so it's £93 roughly. I mean, my calculator's coming up 93.03 if we were going to round this to the nearest penny. The front sheet of this exam says round to 3 significant figures, so you would be perfectly entitled to just go for £93 here. Okay, you can't really do 3 significant figures here because you'd get this, which just looks silly when you're writing it as money. Okay, so you'd just write it as £93. So moving on to part B then, we've already mentioned this, that we're going to prove that this was a minimum rather than a maximum, and it's told us how to do it. It said use the second derivative, okay? But we should know that that's how we do it, okay? So let's just do a quick bit of general stuff. If this second derivative is bigger than 0 at the particular point that we're looking at, okay, then it indicates that it is a minimum. So this is what we're going to be looking for. We're going to be looking to put the values in and we get a value that is bigger than 0. Okay, but we've got to come up with the second derivative first. So I'm going to differentiate this. Okay, so I'll bring the -2 down. So that's going to become 2 times 1500. The 2 negatives cancel out. Okay, v to the -3. And then 2/11 is just a number, so that disappears. Okay, so we get 3000 v to the -3. Again, it might be easier to just write that as this. Okay, now the value that you got in part A was v equals 90.8. Okay, so if we put 90.8 in here on our calculator, we get a fairly small but positive value. Okay, so it doesn't matter that it's only small, it does show that it's positive. Okay, so it doesn't really matter whether it's a big number or a small number. If it's positive, then this is a minimum, and we've proved that it's a minimum value. Okay, and just briefly, part C then, it says state a limitation of the model. You know, how are you going to instruct a lorry driver to drive at 90.8 kilometers an hour for the whole of a journey? It's impossible. Okay, and it's as simple as that, really. Just say something like that. It's impossible for a lorry driver to drive at 90.8 kilometers an hour consistently. Okay, his speed's going to change. He's going to have to stop and start. He might have traffic jams, etc., etc.